Good morning, good afternoon, and thank you for joining our webinar today on Hadoop migration. My name is Clayton Doig. I'm a Principal Solutions Architect with Serata, and I'm joined today by Danny Keating.
Good afternoon, everybody. And as Clayton mentioned, Danny Keating, Senior Director Alliances. I look after our partnerships and go-to-market within Serata. Essentially, what we're going to be covering today, we're going to cover off the business drivers as to why organizations that we're working with and talking to are looking to leverage our tool set to migrate into various different platforms, and Clayton will take you through some of those. What the migration overview is going to looks like, and what we see as some of the migration techniques that organizations are looking to leverage us for. What those pitfalls are, some of the alternative options to Serata, and where those use cases may be applicable. And a question and answer session throughout the discussion. There's time at the end, but if there are any questions that you have throughout the presentation, then I'll keep monitoring the Q&A discussions, and we can stop Clayton or myself throughout the presentation and ensure that we cover off those questions as we go. So why are organizations migrating in the first place? And we kind of look at this in a number of ways. We're seeing a lot of I guess organizations approach us around the sort of Hadoop discussion, and quite often they're due to certain cost savings, license savings, and particularly around sort of Cloudera, for instance, and the support end dates of on-premise CDH. And as we move into sort of CDP, do we want to move into a Cloudera cloud platform? Is it time for us now to go to Databricks? Do we want to look at sort of Snowflake, AWS, Azure? And what we're seeing now is organizations starting to review legacy estates and start understanding whether or not, what does the future look like for those organizations? Do we build on our own? Do we go into a data lake and so forth? So quite often those are coupled in with sort of data center exits or data center costs. So a couple of the customers we're talking to now, one customer is actually having their data center demolished, and they're which is interesting in itself, in sort of 6 to 12 months time. So there's a real time bound need for them to look at what they're doing from sort of a Hadoop data estate. So we're seeing a number of different reasons and as to why, and obviously that then plays into sort of modernization discussions around sort of leveraging some of those best-in-class technologies, like I've mentioned earlier on, Databricks, Snowflake, and really then starting to take into sort of consideration around the AI and machine learning capabilities in some of the hyperscaler platforms, AWS, Microsoft, Google, Oracle, whatever sort of platform cloud you're moving into. How do we look at leveraging those? And ultimately, in most organizations, use cases around unstructured data, and as we're seeing unstructured data grow to go beyond Hadoop into other discussions, a lot of the leverage is becoming around sort of data monetization, and how do we gain that competitive advantage against our competitors around making informed decisions quicker, smarter, and I guess more efficiently.
So with that in mind, migrations are not something that we undertake businesses regularly undertake, especially when going from Hadoop to cloud. And there is a lot of things to think about, to plan for, and to actually execute on. And really where you want to be spending your time is on the building of the data lakehouse environment in the cloud. You want to be setting up all of the different tools that you're going to be working with and making sure that they're secure, doing user acceptance testing, all of these things. And then when you start talking about using artificial intelligence, you're going to be wanting to train foundation models. And to train foundation models, you're going to need to have data there to train those models against. So really what you want to be concentrating on is the building and qualification of that data lakehouse. But what can end up happening is you can get bogged down in what should be, on paper, a relatively simple operation, but as we're going to see, it's not quite so simple. And that is the data migration, movement of the data from the source to the target. And in particular, being able to do that without impacting the performance of the source environment and without having any downtime. But the truth of it is that data can anchor you down. You've got to make choices about how you're going to migrate your data, what tools you're going to use. Do you have the in-house expertise, or are you going to need to outsource to a systems integrator to give you help? Then there's costs associated with this whole project. And I look at it as two different types of costs. There's the cost of the actual project itself. And the longer that that project takes, the more that cost becomes. But one of the modernization benefits that you're trying to get is a cost reduction. You're trying to reduce what you're spending on premise, and you're trying to monetize the data in that target cloud environment. And the longer you take to move the data into the cloud and qualify that cloud environment before you can start using it, the longer that time to benefit is, and that actually reduces the profit or the savings that you're aiming to make in the first place. And with the various tools, there's always a risk of data loss in the transfer of the data. And again, downtime that's enforced on you because you want to make sure that your source and target environments are 100% consistent from a data perspective before any of your users ever start to use the data in the cloud. So there are some traditional migration techniques that we'll talk about today. I'm going to get into a little bit more depth on each of these data transfer devices. Some of you may or may not be familiar with, and we'll talk about those. Distributed copy, native to Hadoop. Hopefully everybody is familiar with distributed copy or DistCP. And then we've seen a lot of businesses try and use a hybrid approach. So we'll talk about how those work and what some of the potential pitfalls are. One of the things that I haven't called out on this slide, and Danny, feel free to speak to this as well. We do speak to a lot of our partners about ETL type tools like Talend and so forth. And we're really not playing in this space. And those tools really aren't big scale, big data migration platforms that are going to take petabytes and petabytes of source data and move that into a target. They're more of an ingest pipeline. Danny, is there anything you would add to that?
Yeah, I mean, having come from that sort of world and worked in the ingestion space with Talend and other organizations, I think that there is a difference, and very much based upon sort of ongoing pipelines and structured data around sort of database, Oracle, etc. And what we see is a distinct difference in the two organizations, and a collaborative approach in terms of us being able to coexist in environments where usual data pipelines are in place around sort of ETL and even some of the CDC tools as well, Clayton, as well, that are out there. We do hear, I guess, certain organizations that is an often discussion that we have early on in some of the qualification discussions we have. Where does this sit alongside? Do I need to remove or take out something like Talend? Where does this sit against my Fivetran proposition? And we are a fundamentally different tool when it comes down to some of the IP and capability underneath the hood around, as Clayton mentioned, that large data scale, the live aspect of it is something that's really important as well from a replication standpoint.
Absolutely. So if we look at data transfer devices just in a little bit more detail, if you're not familiar with what they are, they're essentially a large hard drive. Azure has their data box, AWS has their Snowball. They even have something called a Snowmobile, which is a semi-trailer or a lorry in the UK that goes to your data center, and you load your data onto those devices. It's a point-in-time replica of the data that you have in HDFS, at that particular time. So there's it gets shipped from the vendor to your data center, you do your data copy, and then you ship it back to the vendor for them to load into their cloud object store. Now, I have seen customers try and use some of these data transfer devices, and they've had actually had serious problems just trying to even get those devices to authenticate into their environment because of the way they've had their security set up, various other factors that come into that. One thing that will be guaranteed when you're using the data transfer device is that by the time it gets to the cloud object store, that data will be out of date or stale. And you're going to need to come up with a strategy to then reconcile the differences between what got shipped on the data box and what has changed since it left your data center. The other thing, of course, is that this data box, it's encrypted, or the Snowball, it's encrypted certainly, but it's leaving your data center and it's going out on a courier effectively, and what could go wrong in that data transfer. Could that data actually get lost? Could it get somehow compromised? And then this, we'll see with all three of the approaches that I'm going to discuss, this is going to force a period of downtime upon you as you reconcile the differences between your on-premise data and what's changed since the data transfer device left and what actually made it to the cloud. And then you're going to have to find a way to synchronize all that. That will force you into then doing a big bang cutover. So for example, on Friday, you're working in Hadoop, and on Monday, you're working in the cloud, and there's no wiggle room for mistakes. If things aren't ready in the cloud and you've landed everybody there, you've got yourself a big problem. Distributed copy, and just in case people aren't familiar with DistCP or distributed copy, it is a free open source tool that comes with all Hadoop distributions. And what it does, much like a backup tape, it takes a point in time copy again of your data, and it will replicate it to a source environment. You can run that on a schedule, so maybe once a day or twice a day or whatever that schedule may be, or you might have multiple schedules running against different data sets. In some circumstances, this will actually be a perfectly acceptable approach. If you have a small amount of data that's not changing all that much, then this approach will potentially be quite successful for you. However, if you have large data sets in your Hadoop environment that are constantly changing, and you're talking about having petabytes of source data with potentially terabytes a day being ingested into that environment, you're only ever going to have your data up to date in the cloud as accurate as the schedule you're running distributed copy against. So you could be 24 or 12, what have you, hours out of date, depending on how often you're running that sync. Is there potential for data loss with this approach? Yes, certainly there is. It's a manually set up. You need to know the command line. You could miss and make mistakes in doing that replication job. It also impacts your source cluster. So it runs as something called MapReduce, which I won't get into if you're not familiar, but MapReduce uses memory and processing power. So every time you're running a distributed copy job, you're taking memory and processing power away from the applications in the Hadoop cluster that you're trying to derive business value out of in the first place. This also comes with that period of enforced downtime where you need to reconcile the differences between what's in the cloud and what's on premise. And then again, it forces you into the big bang cutover where you're working in Hadoop one day and you're working in Hadoop in the cloud the next. What we've seen a lot of customers potentially try indeed is a hybrid approach where they're going to use the data box to take a bulk of their data and move it to the cloud, and then try and use, I said, distributed copy to then reconcile the differences between those two storage systems. And what this effectively does is combines the pitfalls of both of the approaches that we've talked about previously into one big list of risks effectively here. And again, you're still forced into that enforced downtime where you need to make sure you're getting the data that's on-prem consistent with what is in the cloud, and then you're cutting over in a big bang manner to that cloud environment. So what does an ideal migration look like? What you would do is obviously start with your data and take the bulk data, and then in real time or near real time, migrate changes as they're occurring. What this allows you to do is, if you think back to the data lakehouse diagram I showed earlier, it allows you to do all of that work around building, testing, tuning, doing application compatibility, getting your InfoSec people happy, user acceptance testing. So all of that can happen before anybody ever touches that cloud environment. You can even in parallel, and this is one of our larger automotive customers, one of the things that they were able to do is train their data scientists, in this case on Databricks, before actually migrating to the cloud properly. And this allowed them to learn how to use Databricks and also compare and contrast the results they were getting on-prem versus in the cloud to make sure that everything was consistent. Once that's all done, then you can start to move some of the various ingest pipelines, workloads, and indeed groups of users that you have from your source environment to your target environment. You'll have multiple ingest pipelines, and they'll be associated with different workflows, different groups of users. So you can do that in a very staged and managed approach. And this brings you to the point of business as usual. You're now realizing the data modernization that you set out to achieve, and you can run in a hybrid mode for a period of time if you need to. But if cost savings was also a driver of this, this allows you to then sunset your on-premise environment. And we certainly had a large auto manufacturer in Germany do exactly this. They didn't want to renew their Hadoop licenses. So the day before they were due to renew their Hadoop licenses, they had used our technology to migrate to Azure, and their on-premise cluster was shut off, and they didn't pay that annual renewal. And of course, this is where we come in and where we play. And this is our actual sweet spot, is our product called the Data Migrator. It's an automated product that's very simple to install. It's easy to use. We'll show you that here shortly. It replicates in near real time, and it allows for the ideal migration that we showed on the previous slide, where we're moving the data first, doing all the prep work in the cloud. Everything is controlled, and then we're able to kind of seamlessly move the ingest pipelines, the workflows, and the groups of users into the target. It installs on an edge node of a Hadoop cluster, and what it'll do is a single pass scan of your file system. It will migrate the data that it finds, and then it will leverage the iNotify functionality within Hadoop to be made aware of new writes, appends, deletes, whatever file system operation that is happening. And we will replicate that as soon as the write is complete at source. We will start migrating that new file or changed file up into the cloud object store of your choice. We ship with a UI that you can use to manage the entire solution. However, you can use our own built-in command line, and we do expose a REST API for those that want to automate things and control things scriptomatically. So with that in mind, we'll have a little look at a demo. In my case, what I've chosen to do is set up replication between a Hadoop environment and AWS. That's going to be AWS S3 and an AWS Glue catalog. And I'm starting on premise with a simple database that I've created. We'll get into the details of this database shortly. And from a target point of view, I have my S3 bucket that currently has 3 folders in that. We'll refresh that later just to make sure that that's up to date. And then we have our Glue catalog. When we run queries, we'll be using Athena to do those queries. So when we set up the migrator, obviously we want to know what data we need to migrate. So as you can see here, I'm using a small database called cars, and I've got a single table called inventory. Now the inventory table lives in this directory in HDFS. So that's, for those of you who know Hive, that is a managed location, but we can also do unmanaged tables and partitions and what have you. Selecting all of the data from that inventory table shows us it's not very big. I've kept the data set small on purpose, for the sake of time and expediency. We don't want to be sitting here watching a terabyte replicate. This is our UI, and we base our initial setup on the creation of file systems or agents. And again, if you don't want to do things through the UI, you can do everything that I'm describing through our command line and through our REST API. If we dig into the system a little bit, we'll see that we've got some file systems defined, and we've also got some metastore agents defined as well. And we'll talk to, replicating not only HDFS data, but Hive data as well. When we install on a Hadoop cluster, we'll attempt to automatically discover everything about that cluster. Now, typically, clusters are Kerberized. You'll need to add a principal that we will run as, which would be an HDFS super user type account with the associated key tab. Once you've done that, your auto-discovered HDFS will come up healthy. From there, you can start to add your target file system. So we've got AWS S3, which we're going to give a free text display name. I've called mine CDS3. We give it the bucket name. And then we have multiple different ways in AWS which we can authenticate against that storage. I'm using the secret key and access key method here today. Then we provide our service endpoint. And if we need to configure other key pair values to authenticate and connect to that storage, we've got the ability to do so. Click save, and that becomes a healthy agent. Again, with Glue, and this is for Hive metadata as well, we would set up the storage that the catalog is associated with, so it knows where to read its data from. We'll give it a free text display name. Again, we're using the secret key and access key method, and we're providing an endpoint. If you don't know your endpoint for your Glue catalog, you can click on that link, and that will take you to a list of documentation for AWS, which will show the relevant endpoint to your region. And in my case, I'm running in Canada Central. We don't have to worry about the default file system override. Once we've added that agent, we can then start on the concept of doing migrations themselves. So you can see setting this up is actually quite easy. From a migration point of view, we will do a data migration first, and we're going to give the migration a name. We're going to call it cars after the database that I've selected, and we'll select our target. Autocomplete did fill in the path to that because I'd done this previously. What's not shown on the screen is a link in the right that says browse file system. So if you need to browse your file system, show folder browser will allow you to do that. The other thing I've done in this demo is I want to bring out our path mapping feature. We all know that data lakes over time can become data swamps. There's different naming conventions that come into play, what have you. So what I'm going to do is I'm going to take anything that's in user Hive warehouse, and I'm going to land it in a database folder in S3 or databases folder in S3. Target match is a feature that will completely overwrite your target, and that will guarantee that you are a 100% consistent between source and target. So if there's any files there that you want to preserve within that databases folder, for example, don't enable target match. You can actually, if you look below, see skip if size match, and that will preserve your data. We can also exclude based on date, age, regular expression, file size. We won't look at that today, but just to call out that capability is there. We do different types of migrations, live, recurring, single scan. We're going to go with live for the purposes of today, and this will leverage that iNotify functionality that we talked about from the name node in Hadoop. We can also then prioritize our migrations, normal, high, and low. So if you have data that you're looking to get to the cloud more quickly, you want to prioritize various business units, then that is certainly something that you can do by selecting the migration priority. Okay. There are other options for migrations available. We'll keep it relatively simple for today's demonstration. We'll then click Auto Start, which will automatically start that migration as it says. This will flip us back to our home screen, and in a second, you'll see that the cars migration goes live. So now we've migrated that existing data, which admittedly is not a lot of data, and we are now monitoring for any changes. The next step we'll do is a metadata migration. And again, we'll call this cars. We're going to choose our source Hive agent, and then we will choose our target Glue catalog. And we've built some name pattern matching rules within the tool in advance of the demo. And I set one up that says anything with a table name of cars or a database name of cars with any table is something that we are interested in replicating. So this is going to respect that pattern matching rule. And before we set up that migration, just to confirm in Athena, we only have our default database present. So we haven't moved anything just yet into that environment. So I can go ahead, select Start Migration automatically, and click Create again, and the same process will start. So we'll see our migration listed. This will very shortly go into a live state. So now, if I go back to Athena and S3, if I refresh, I see I have my databases folder, and within that, the cars and inventory subfolders with that single text file associated with those 3 forwards that we saw in the on-premise query that we ran in Hue. If I then flip over to Athena again, and I do my show databases again, we can see the cars database is now present. I can refresh my databases view and see that we're now using the cars database. So let's select star from inventory, and let's see if we're consistent with what we have on-prem. So we can see here that we've replicated that exact table as we showed you at source before we started setting up migration rules, replication rules. So flipping back to source, because this is, to be honest, this is something you could do with this CP. But flipping back to the source, this is where we come in and where we are very different, pardon me, to any of the other tools that you see on the market. It's not just about migrating the pre-existing data. And again, this can be petabyte scale. we're also about taking any of the changes and replicating those in near real time. So what we'll do is we'll insert a small amount of data into this inventory table so that we have some new data to look at. We'll run that same select statement from Hue, in this case, the source environment, and that will show us that we have some new data to actually look at. And as you can see here, I've added basically 3 Subarus to my list of car inventory in my imaginary company. So if I run my query again in Athena, we can see that without me touching the Sirata UI or any of the command line, those 3 Subarus have already migrated up into that cloud. And then for the sake of completeness, we can see that second text file that we added to the database has also been added into the S3 bucket. There's a lot more that we could show you in terms of functionality, integrating with LDAP, rule-based access control, bandwidth throttling. There's a lot of features to that. But really, that's the core of what we do. We will take the bulk of your data at petabyte scale and migrate that up into your cloud of choice, and then we will capture the changes in near real time and move those as well.
And
so
I guess just on that, Clayton, some of the just going into some of those use cases, you know, we have use cases where we've gone upwards of 20 petabytes and above in certain organizations where we've moved and migrated and brought down sort of migration timelines from 2 years to 1 year and enabled greater sort of enhancements around speed, time to value in terms of projects that have then been released to drive that sort of monetary value into an organization. So that's the real crux of where we can come in and help. And there are many use cases like that.
Absolutely. And what we're really aiming at is freeing you up to do the build of that data lakehouse that we talked about earlier in the presentation. Don't worry about spending a whole bunch of time on a skill set that you don't necessarily have in-house, data migration. We can come and we can help you with that and allow you to free up your resources to concentrate on where you're going to derive the most business value. We're running quite short on time. We'll open it up for Q&A. If you don't get your question answered today, then obviously please feel free to reach out. You can contact us directly here, or if you want to read more, this is a link to our documentation, and you can just go to docs.sirata.com, and that will take you to this. So are there any questions? So I've got a question here is, what are the clouds that you can migrate your data to? We'll target all of the major cloud vendors in Google, AWS, as we've seen, Azure. We can also target the IBM cloud. We can target the Oracle cloud and the Alibaba cloud as well. So we're very agnostic in terms of which clouds we can migrate to. And I've got another question in terms of what other sources do we support? So we're not just a Hadoop migration tool. We can do on-premise storages such as NFS, mounted file systems, network file systems, local file systems. And we can also migrate from a cloud object store to another cloud object store. So that might be trying to avoid vendor lock-in, or that could be, you know, for a DR strategy between clouds where you don't necessarily have the control of the regions you want to replicate between exposed to you by that cloud vendor.